Hello, Math 120. And this is Professor Gonzalez, and I'd like to take a look at some homework problems from section 4.8. Now, 4.8 happens to be the section that talks about polynomial equations. So you've got these polynomial equations, and we're trying to solve the variable, usually, well, in most cases x, but it could be any variable. And it really relies on this principle called the zero product property. And that states that if you have the product a times b, and that product equals 0, then either A equals 0 or B equals 0. I guess we have to put it right here too. And you have your little pull down menu which says A equals 0 or B equals 0. So what I'd like to do is take a look at one of these problems. So I would like to do number 5 first, actually. Whoops, this wasn't supposed to happen. I'd like to do number 5. Let's do number 5 down here first, just so I could kind of give you kind of some of the rationale with this. I think it makes sense to do it this way, at least when I teach it. So what is number 5? I just lost it. Number 5, okay, number 5 is x squared minus 12x plus 32 equals 0. And darn it, let's see, that's going to be in the way of my next problem, so I better move that down here. Use my new trick I learned. Okay, I think I have space to... I think I have enough space for that. I'm going to move it again. Anyhow, so if you take a look at this, what this is saying is I'm looking for a number x that when squared, and that same number x is multiplied by negative 12, and then you add those results together, and then you add 32. When you do that, right, you get 0. So I'm looking for x values that will make that left side equal 0. Now, that is actually a really hard problem to figure out, right? I've got some number that gets squared, that same number gets multiplied by 12, and then you take the difference of them, or multiply by negative 12 and add them into either the same thing. And then after you do that, you add 32, and magically you get 0. I think you're going to be guessing and checking for a long time. So that shows that these polynomial equations are a little bit complicated when they're written in this standard form. But if I could somehow write this complicated polynomial as a product, then I get this nice, easy zero product property happening here, where then I know that this factor must equal 0, or this factor must equal 0. And it turns kind of a nasty problem into an easier problem. So can we turn this into a product? And yes, that's called factoring, right? Now remember, I keep on calling these, when you have a quadratic that has a leading coefficient of 1, I call them easy. Right? I call them easy because all you have to do, that's not the color I wanted, all you have to do is see what two numbers will multiply to 32 and will add to negative 12, right? I got that right there and there. And what is that going to be? You could start searching around. Of course, if you know they're going to add to a negative, they're both going to, and it's going to multiply to a positive, they both have to be negative, right? And you can start taking a look. Okay, I already know the answer, but let's just act like I don't. And you might say 1 times 32, 2 times 16, 3, how about 4 times 8? And oh, wait a minute, 4 times 8 sounded good because that adds to 12. So how does that work? Well, a negative 4 plus a negative 8 equals a negative 12. And when you multiply a negative 4 times a negative 8, you get a positive 32. So those are the numbers. So now this polynomial factors down. Remember, once again, because this is an easy problem, we just go ahead and write our factors down. And that's why is it an easy problem? Because the leading coefficient is a 1 in red. You can see it. So x minus 4 times the quantity x minus 8, and that equals 0. Now, here's the magic. It's not magic. Here's the property working. We have the product of two factors equaling 0, and that's a powerful thing because now I can say for certain x minus 4 equals 0 or x minus 8 equals 0. Now look how easy my equations are. Instead of having that big nasty equation with a square and multiple places you have to put the variable, you've got this simple equation. How do you solve for it? Of course, add 4 to both sides, and we get x equals 4. Of course, add 8 to both sides, and we could just mentally do this, I think, and x equals 8. We got two answers. So not only one answer, there were two answers out there. And trying to figure that out in standard form, I think was going to be a nightmare, especially trying to get both. But once you factor it right there, of course it has to be equal to 0, and then factor it, then you have two nice little easy equations to solve, and it turns the problem into an much easier problem. So this is a zero factor property. This is what we're doing in this particular problem set. So I might as well write down the answer. We just did number 5, and we got 4 and 8. We just did number 5. We got 4 and 8. All right, done. Okay, let's go up to the original problem and continue. Use the zero product property to solve the equation. Well, the beautiful thing here is it's equal to 0, check, and it's already factored, check. This thing is pretty much done for us. X times the quantity x plus 17 equals 0. We have factors, and it's equal to 0. So set the first factor equal to 0. First factor is x equals 0. That looks done. Set the next factor equal to 0. X plus 17 equals 0. Subtract 17 on both sides, and we get the answer of x equals 0 or x equals negative 17. Now the order that I tried both ways just to see. If you write down 0, comma, negative 17 or negative 17, comma 0, it's just a list, and so my lab will take either way of those. So that's good. Ooh, I did not leave a lot of space because I kept on playing around the position of number 5. But I think we're still in good shape because look at this one. It is equal to 0, and we have two factors equal to 0. So this thing is ready to go. Basically, I'm going to write it down again. Basically, we have x minus 2 times the quantity 2x plus 1, and that equals 0. So using the zero factor property, this means that x minus 2 equals 0, so x equals 2. Or, zero factor property says the other factor, 2x plus 1, must equal 0. Subtract 1, 2x equals negative 1. Divide by 2, and therefore x equals negative 1/2. So we get two answers. And like I said, it doesn't need to be in ascending order from smallest to largest, so 2 or negative 1/2. And that's the answer. Those are the answers for that particular problem. Okay, so now let's see, get this to fit the screen. Let's move on. Now they're going to give us a step-by-step play here. And so I really that's why I did number 5, because the problem was maybe a little easier than this one, but then it just gives you that holistic idea, once again, I think it does, that you're trying to solve for x, and it's really hard to do when it's in standard form. So why don't we factor it so it's a product, two products or two factors that equal 0, and now it's easy. And really gives us a real good reason. Why did we learn how to factor, right? Meaning this polynomial is equal to the factored polynomial. So why the heck would you do it? Well, one great big reason is that now that their factors equal to 0, I can solve much easier. So now we're going to do that problem here. They're doing a step-by-step to just make sure you know the steps. Step number 1, write the quadratic equation in standard form. Okay, this particular one is not in standard form. You can see it's equal to 6. So you subtract 6 from both sides, and they're telling you that right there. And when you subtract 6 from both sides, you get 9x squared minus 53. I'm going to start that again and try to zoom in so it's a little easier to do here. So we've got 9x squared minus 53x. I'm just copying it down. Now subtract 6 from both sides, and you got minus 6 equals 0. Of course, they verify it right there on the next step. There it is. Okay, the next step says, please factor the expression on the left side of the equation. Yeah, now this is going to take some work, right? Because this is factoring a problem that is, I wouldn't call it easy because of that leading coefficient, right, is something other than 1. So how do we do this? Let's zoom in a little bit here. And I think maybe I use a little bit of color. Make sure that's not too big. Probably good size right there. So now we look here and we can see the leading coefficient's not a 1, so it's not as simple. We must multiply 9 times negative 6. So we're going to say what multiplies, so 9 times negative 6 is negative 54. So what two numbers multiply to negative 54, and we'll add to that negative 53. So we're multiplying to get a negative, and we're adding to get, so if you're multiplying to get a negative, one factor has to be negative and one has to be positive. And you know, one of the factors that people often forget about is 1 times 54, right? So if I have 1 times 54, I can see that if I take a negative 54 times a 1, I get negative 54, so that works. But a negative 54 plus 1 gives me my negative 53. So these are those two target numbers that I'm looking for. I'm going to make those blue. And space-wise, yeah, we're a little tight on space for this problem. Doing all this factoring in this tiny space. So remember we had, I'm going to write this up here. Remember we had 9x squared minus 53x minus 6 equals 0. Actually, right now all we're doing is factoring, so I'm not going to worry about the 0 part. We're just factoring. So remember what happens next is we replace this blue, these two blue target numbers, with that interior, right? So we know, let me get rid of that so I have some space to operate. I've got 9x squared. I know that negative 54x plus 1x actually does equal, right, this negative 53. So that's all good. I'm going to copy down negative 6. Now we look at these two right here, and we factor out a common factor, and that common factor is going to be 9x. What is remaining when we factor out a 9x is x minus 6. So I know with my next two terms, I must have an x minus 6, otherwise factoring by grouping will not work. So how can I get an x minus 6 when I want x minus 6? I'm just going to factor out a 1, right? 1 times x minus 6 is still x minus 6. And now I can see the common red factors factor out, giving me x minus 6 times the remaining black terms, which become times 9x plus 1. So we get x minus 6 times the quantity 9x plus 1. It's factored. And you can see that's what they got also there. They have 9x plus 1. That's what we got. And so that's that one right there. And then I guess they want us to write down the other one, the other factor, using the zero factor property. 9x plus 1, I'm sorry, in black, was right here. And then they want the other factor we'll do in red, which would say or x minus 6 equals 0. Okay? Then we go to the next step, solve each easy first degree problem, right? The one in black. This one has a little more work because it's more than one step, but it's not that bad, right? 9x plus 1 equals 0. Subtract 1 on both sides, which gives us a negative 1. Divide by 9. and x equals -1/9. And then on the other hand, this red one, it just says x minus 6 equals 0, add 6 on both sides, x equals 6. So that one's was even an easier problem. Now they're saying if you want to double check it, you have to take this value that we got right here, x equals -9, and substitute it in to the original equation and see if the left side actually equals 6. And when we do that, it's true, the left side does equal 6. We add another one to work, remember the black one? This is if you want to check it, and you don't have to check. I would say if you have time at the end of a test, check, but if you got a whole test to do, I don't know if I'd do all of this. I've actually seen people spend time on this, then they get the right answer, then they go for the check, they mess the check up, and they erase all this great work. So, you got to watch these checks sometimes. This one's a bit long, and I could see a mistake happening. I think you need to get your work done first. Then you could breathe out a little bit and maybe do some checks. This one, once again, if we wanted to check and see if 6, remember we said 6, x equals 6 is a solution, you'd go back to the original problem again and substitute in a 6 for the original equation and see if the left side equals 6, and it does. So therefore we know, true. Those two answers do work. What were the two answers? The first one I had in black, which was -1/9, and I also had one in red, which was what? +6. There you go, -1/9 and +6 are my two answers. We already did 5, awesome, right? We did that at the very beginning. Let's do number 6. Now number 6, let's see. Number 6, the problem with number 6 is it's not set equal to 0. It's not set equal to 0. So that's our first step. So how do you set it equal to 0? Basically subtract 6w off of both sides. And what do you have left when you subtract 6w? You got 3w squared minus 6w equals 0. That's what we have. Next step, factor out. Now it's just a binomial, right? It's not a trinomial. First thing you do with a binomial is factor out the greatest common factor if you can. And then the next thing you do with a binomial is see, does it fit into one of those 3 binomials that factor? What were those again, just as a review? Well, just as a little review, does it fit into the model of looking something like this? A squared minus b squared, right? If it does, it's just going to be a plus b times the quantity a minus b. Does it fit into the second possible model, a cubed minus b cubed? And if it does, I don't think I have space to write all that out, but I put that on the last one. Well, I feel like I got to do it now. A minus b, if I zoom in, a minus b times the quantity a squared plus ab plus b squared. And then there's only one other possibility, and that would be a cubed plus b cubed. And if it falls into that pattern, then we're talking that'll factor down to a plus b times the quantity a squared minus ab plus b squared. Okay, so we kind of jumped the gun, right? I don't know if it fits in any of those patterns. That was just a review, really. That was extra review. Okay, so the first thing we want to do with this binomial is see what factors out. And I see a 3w factors out. What's left? W minus 2. So w minus 2 is a binomial that does not fit in one of these. So I know I'm done, it's primed, it's finished in terms of factoring. So now we've got a factor. Actually, we got 3 factors if we want to count 3. 3 is a factor times w times the quantity, or the quantity w minus 2. So now it doesn't make sense to set a 3 equal to 0 because 3 can never equal 0, right? So you're not going to take a constant and set that equal to 0. But whenever you have a variable like w as a factor, you set that factor equal to 0. So we already have one answer. W equals 0 is going to work. And then let's take a look at what makes this factor equal 0. So W minus 2 equals 0. So W equals 2. So we actually got three answers. Oh, no, two answers. Sorry about that. We just got two answers, 0 or 2. And then we move on. So this is now what, number 7. Let's see how much space I have to operate. Number 7. Okay, now number 7, as you know, I like to identify. Now, first of all, very first, this must be set equal to 0, standard form, right? It is. Now, second, let's factor. I'm going to identify this as an easy factoring problem because of that 1. So that kind of makes me a little more relaxed, knowing that all I have to do is multiply, see what multiplies to negative 7, that guy, and adds to 6, that guy. And if I'm going to multiply to a negative, one has to be negative and the other factor has to be positive. And if I want to add to 6, I'm thinking, how about, whoops, just changed something. How about positive 7 times a negative 1 gives, and we multiply that, I get negative 7. When I add them up, I get positive 6. So these two numbers are my target numbers that will replace 6z, right? Because it adds up to 6z. So now my new equation, so let me show my work a little bit more. We got z squared plus, whoops, you know, I'm making this hard. I just told you it was going to be easy. Once you have a 1 in front and we call it easy, we don't have to do this step that I was just talking about by replacing and then factoring by grouping. It'll still work, but it's way more work than you have to do. Once we have identified this as easy, sorry, I lost my brain for a second there. Once we identified that as easy, I want to save some time because I know it's just going to factor down to, and I better use the right variable, it's just going to factor down to z minus 1, that guy, times z plus 7, that guy. And once again, if you accidentally grouped it and did all that, substituted this for, 6z, you'll get the same answer, but you're going to notice that, man, it's a lot more work, and I already have the answer. So now let's realize that the zero factor property is going to apply here. A factor times a factor equals 0. So why don't we set z minus 1 equal to 0, and we've got one answer of 1. And why don't we set the other factor equal to 0, z plus 7 equals 0, subtract 7 on both sides, so z equals negative 7. And I've got the second answer. So negative 7 and 1, or 1 comma negative 7, doesn't matter in terms of reporting it in my lab. Next problem. Okay, is this equal to 0? No, that's a massive problem, because if it's not equal to 0, look at that right there, it's equal to v. If it's not equal to 0, you cannot use the zero factor property. So the very first thing we better do is we better subtract v from both sides of the equation. And what we do when we get that is v squared minus negative 19 minus 1v. So negative 19v minus 1v gives us minus 20v plus 100. And then we get that awesome 0 on the right-hand side. Now, once again, when I see this, I get a little bit happy because I see that it's easy because of that 1. Let me try to take my own advice this time and realize that all I have to do is multiply, see what multiplies to 100 and adds to negative 20. So notice that we're multiplying and getting a positive, yet we're adding and getting a negative. This would indicate that I have to have two negative signs, meaning a negative times a negative will give me a positive, so that works. And when I add two negatives, adding two negatives, right? You borrow money from one person, you borrow more money, it's going to be negative. It's getting worse, right? You owe even more money. So we see how that works. So we need to figure out two numbers that will fit into this little model here. And some people look and test and check, and some people just look at that and go, wait a minute, what about negative 10 times negative 10 is 100, and negative 10 plus negative 10 is negative 20? Yeah, so some people see it real quick, and other people, you're just going to have to see what multiplies to 100 and start just writing some factors down until you start seeing it, right? And then, the more you do with it, the more factoring that you do, the quicker you actually get there. A lot of times, after a while, you don't even do this stuff because you can kind of hone in on the answer right away. Alrighty then, so because of that 1 in front, we do know that this is going to be a quick factoring problem. It's just going to be v minus 10, which is that guy, times the quantity v minus 10, which is that guy. Wait a minute. Oops. That wasn't supposed to happen. I was trying to act surprised, and then I hit the wrong button. There we go. So wait a minute. Wait a minute. This is a perfect square, right? This is the same thing as v minus 10 quantity squared. Yes, you are right. In fact, if we go back to this problem right here, if you're kind of really on it with that formula of a perfect square trinomial, you could have factored that using that formula of a perfect square trinomial. On the other hand, because this is, we would call this an easy problem with that 1 there, it's not that bad factoring it using this technique that we just did. So the question is, how many answers am I going to get? Well, I set v minus 10 equals 0, so I get v equals 10. And, oops, that's a little sloppy, v equals 10. And you guessed it, when you set the second factor equals 0, you also get v equals 10. So you only write it once. This is called a double root. This is called a double root. And you only write it once. So v equals 10. All right, let's take a look at the next problem, number 9. So the good news is equal to 0. Yay. The bad news is we have a 5 there. So we don't have our super, super easy situation. So let's go ahead and say 5p squared. Now wait a minute. I can go ahead and go forward saying this is not an easy problem, and that would be just fine. At the very end of the problem, I would have to factor out the greatest common factor if there is one, and there is a greatest common factor. So you would be much better off factoring out the greatest common factor right now. Not that it wouldn't work the other way. It would be because if you factor out the greatest common factor right now, the numbers are easier to work with. So you might as well do it right now, right? What is common? 5 is common. So you factor out a 5, and you get p squared plus 2p minus 8. I don't know about you, but I'd rather factor with a 1 here, with a 1 there, which means now it's easy, and a 2 there instead of a 10, and a negative 8 instead of negative 40. Yeah, this is, I'm getting choked up here, not because I'm getting sentimental because it's such an awesome problem. I'm just need a little water here. This is an awesome problem though. Anyway, so when you take a look at this, this is now an easy problem. What multiplies to negative 8 and will add to 2? Right? To multiply to a negative, we must multiply a negative times a positive, so we know the signs. If you're not seeing it, then start writing your factors. 1 times 8, 2 times 4. Oh, wait. So how about a positive 4 and a negative 2 multiply to negative 8, and we'll add to positive 2. So there it is. Once again, being that, what color did I use when it's easy? That's what happened. I didn't use my right color last time. I try to color coordinate this stuff. So, right, this is an easy problem, so all we have to do is just kind of write down the answer from this point. P minus 2. P plus 4. And that all equals 0, as it did at the very beginning. Now you set each factor as equal to 0, not a constant though, because 5 doesn't equal to 0. That's not going to work. P minus 2 equals 0. Add 2, so we see that P equals 2. There's an answer. Set the next factor equal to 0. P plus 4 equals 0. Subtract 4 on both sides, and P equals negative 4. There's our next answer. So we get 2 and a negative 4. All right. Moving on. Oh, good news equals 0. Bad news, that's not 1. Worse news, it's a fraction. Okay, why don't we clear the fraction? You could always clear fractions whenever you have an equation. So let's do it. You don't like that fraction? Multiply by the common denominator, and if you want, you could see all these denominators are 1 really. So so the common denominator is just 2, right? 1, 1, 1, and then this is a 2. So we multiply each term by 2, 2 over 1 if you will. So multiply every term on the left by 2 and multiply everything on the right by 2. Well, here's what happens. Let me zoom out a little bit close, and let's write the results down here. 2 times 1.5, or half of 2, is just going to give us 1x squared. And 2 times 2x is 4x. And 2 times a negative 7 is negative 140. And 2 times 0 is just 0. Okay, so clean that up a little bit. So we have, now the numbers did get bigger, but you don't have fractions. So it's definitely a huge plus. And even better than that, wait a minute, that's a 1. This is going to be easy. So what two numbers multiply to a negative 140? Okay, 140 is kind of big, or small, negative. And add to 4. Let's see. If I'm going to multiply to a negative, I got to multiply a negative times a positive to make that happen. And the signs are opposite of each other, so when you add them together, really we're subtracting two numbers. We're finding the difference of two numbers to get to 4. Those two numbers have to be kind of close to each other, right? They have to be within 4 of each other for that to happen. So that's, I'm saying this, I'm hopefully that's not overly confusing, but what I'm saying is, because the difference is 4 really, if you start with 1 times 140, there's no way that's going to have a difference of 4. So, you really could, you go, okay, what about 2 times 70? Man, those two things are so far away from being a 4 that, you could kind of maybe save a little bit of time, maybe drop down to something that's a little closer. Now, if you find yourself just missing the right factors, then maybe you should systematically just go down the list, right? But, so this is something that you could kind of mess around with. What two numbers? I mean, sometimes realizing that if it ends in a 0, that would be 14 times 10. And wait a minute, I just lucked out, right? In some ways, there it is. So 14, positive 14, and add that to a negative 10 is going to give us a 4, and it's going to multiply to negative 140. Because this is an easy problem, all I have to do is write down the answer. X minus that guy, 10, times the quantity x plus that guy, 14, equals 0. Use the zero factor property. X minus 10 equals 0, so therefore x equals 10. There's one answer, 10. And then set the second factor, x plus 14 equal to 0. Subtract 14, and x equals negative 14 on both sides, right? So x equals negative 14. So there's my second answer. So it should be 10 and negative 14. 10 and negative 14. Once again, that order, if you wrote negative 14 comma 10, you would still be given full credit, and they would give you their nice little word of affirmation like fantastic or you're awesome. I don't know what they say. You're awesome. Do they use that one? I think they use excellent, fantastic. I don't know what else. Maybe we should reprogram, have some more modern words in there, but I don't know. Then I wouldn't understand it because I'm not too old. So anyways, let's take a look and see what do we do next. First of all, when you take a look at that polynomial, you will see that it is not equal to 0. That is a big problem. It is already factored. Darn it. The left side is factored, which is the kind of the pain in the something part of this process. It's already factored for us, but we cannot take advantage of that because it's not equal to 0. So let's start this thing off here. This says x plus 4 times the quantity x minus 1 equals 2 plus 2x. And I got to just blow this up by multiplying the left side out. Unfortunately, I can't take advantage of that factoring because I need to combine my like terms. I need to have it equal to 0. So the first thing you multiply, x times x is x squared. X times -1 is negative x. 4 times x is 4x. 4 times -1 is -4. Combine your like terms over here. X squared minus x squared, and then a -1 and 4 is plus 3x. Man, I don't know if you can hear my stomach, but it is growling like crazy. I'm starving to death here. So anyways, now we want to set this equal to 0. So we better subtract 2 off of both sides. I'm going to subtract my like terms. And we also better subtract 2x off both sides, like terms. And finally, what does that give us? X squared plus x minus 6 equals 0. So look at all that work just to put it in that standard form so we could now factor and use the zero factor property. So that one was really a pain. You know, we thought that they were being nice by factoring it for us, but the fact that it was not equal to 0 really ended up being no help at all. So we have this thing simplified or in our standard form of x squared minus x, x squared plus x minus 6 equals 0. The good thing, finally a good thing, the good thing is it's easy now because of that 1. So we will take a look. What multiplies to -6 and adds to 1? No problem. 3 times a -2 is -6, and 3 plus a -2 is 1. So this just factors down, and I'll use my colors just to show it's easy. That's an easy one. X plus 3 times the quantity x minus 2 equals 0. Set each factor equal to 0. X plus 3 equals 0. So I'm really out of space. X equals a -3. Whoops, that just jumped on me and screwed it up. -3. And then this one, what's going on here? Then this one is set this second factor, x minus 2 equal to 0. Add 2 to both sides and x equals 2. And so we get a 2. So we have two solutions, a -3 or 2. Moving on. Solve the equation. Okay, now they're getting a little tougher here, maybe. Not equal to 0, so scratch that. So the very first thing we want to do is, how about if we subtract 18x from both sides? Because we want this to be equal to 0. So now I've got negative 6x cubed plus 39x squared minus 18x, and that all equals 0. So we do really need to factor out the greatest common factor. There's a negative in front, that's nasty. There is a common factor of at least a -3, so let's do that. And I also see an x on each one of these terms, so let's factor out a -3x. That's going to leave us with, what's that going to leave us with? A 2x squared. And then we get negative times a negative is positive, so that's going to be, isn't it 13, I believe? 13x. And then once again, we're factoring out a -3 from this, so that's going to be a positive 6. So, you know, once again, to double check this, you could always just mentally double check this. A -3 times 2x is -6x cubed. Especially when you're factoring out a negative, it's easy to make a mistake. -3x times -13, so -3 times -13 gave us that positive 39, right? And then x times x gives us x squared. And then finally, -3x times 6 is -18x. So you can run through that just to make sure you're good to go. Now the next step that we need to do is we need to factor this. Now, This has a leading coefficient of 2. Now this is already factored out, so that this part is out. We do need to carry it down as we work the problem. But we would not call this one as easy because it has a 2. So how do we deal with this? I use a different color, and I take the 2 and multiply it by 6. So that's where we got that, right? So that's 2 times 6 is 12. What multiplies to 12 and adds to negative 13? What is that going to be? How about a negative 1 times negative 12? Negative times a negative is positive, and negative 1 plus a negative 12 is negative 13. So now this is not the easy type. So what do we do with this type? We take those two target numbers and replace negative 13x with that. So let's see what we have. Don't forget to bring this down, but I'm not gonna write it down right now. I've got 2x squared. I'm gonna replace negative 13x with, you can put the negative 1 here, or you could put the negative 12. Usually doesn't matter. Every once in a while it does, the order of that. I'll just put negative 1x. So what does negative 13x equal? Well, it equals negative 1x minus 12x. And then I'm just going to copy down this yellow 6. And here we go. And you know, I think what I'm going to do is just write this down. Sometimes you could just bring it on down, but don't lose it. That's the thing. That's what really gets us. So now what we have to do is we have to factor this by grouping. What is common? Well, I'm seeing that an x is common. So what is left if x is common? What's left is 2x minus 1. Now with the next two terms, we must factor something out to get 2x minus 1, because those two golden binomials have to match. If they don't, try something different, because it won't work if they don't match. What can I factor out? Or another way to say it is, what times 2x will give me negative 12x? And I'm thinking, how about a minus 6? Negative 6 times 2x is negative 12x, and then you got to check it. Negative 6 times negative 1 gives me that positive 6. So that is all good. Now, what I want to do is I want to finish up. What's in common? Well, these two binomials are the common factors which factor out 2x minus 1. What's left is those terms inside there are left as x minus 6. Never forgetting what we originally factored out is right there. Never forgetting it's all equals 0. So we could apply the zero factor property. Well, we've got we really have 4 factors, but remember, constant values are not going to go anywhere in terms of solving for x, but there is a variable there. So that we set equal to 0, and we already have our first answer, x equals 0. We set our second factor equal to 0, 2x minus 1 equals 0. We add 1 to both sides, we divide by 2, and we get our second answer, x equals a half. And finally, we set our last factor, x minus 6 equal to 0, add 6 to both sides, and x equals 6. We got our third answer. So in this particular problem, we have 0, 6, and a half. 0, a half, and a 6, however you want to say it. 0, 1 half, and 6. Okay. All right. How about a word problem to finish off the day, huh? This says a farmer has 140 meters of fencing. Farmer has 140 meters of fencing, wants to enclose a rectangular plot that borders river. Okay. If the farmer does not fence the side along the river, that sounds risky. What are the dimensions of the land enclosed if the area enclosed is 2,000 meters squared? So they're saying that this is 2,000 meters squared. And they're saying the total fencing around, and only uses 3 sides. Let's put some notes up here. So here's what I'm saying. Here's what I'm thinking. I'm going to go ahead and let me try it again. I'm going to go ahead and call this side of the enclosure X. Now, it is a rectangular enclosure, so opposite sides on a rectangle are equal. So we got x and x. Something that we got to be a little bit careful with. I'm going to call this y, and maybe I'll use a different color. I'm going to call that y. But if I don't do something else, I'm going to have too many variables in my equation that I'm about ready to get here. So let me take some notes. The fencing that they have to work with, you see here, is 140 meters of fence. So really what I can say is I can say x plus another x, right? So there's an x here, there's an x there, plus what else? The side, I've got this y value right here, plus 1y. The water's taking care of the other side, must equal the total amount of fencing that I have. And they told me that I have 140 meters of fence. So, of course, when you simplify this, you get 2x plus y equals 140. And if you simplify that further, we would say y equals, how about if I subtract 2x from both sides? And if I subtract 2x from both sides, I get 140 minus 2x. So I'm going to replace this y with y equals 140 minus 2x. Let's see if that makes sense also, right? So you start off with 140 meters of fence. You use some of it over here, that's x. You use more of it over there, that's 2x. So you have 140 meters of fence. You use x and x, so you subtract out 2x. What do you have left? The last little bit, which is y. So yeah, that makes sense. Okay, so now let's go ahead and see what we've got. Let's come down here. And what we need to do is we need to remember that length times width equals area. So the area of this enclosure is 2,000 square meters. And the length I can see here is this x. And the width is y, but I don't want to use a different variable. I can actually see that I can write the width in terms of an x. That's just 140 meters of fence minus 2x. So now I've got a quadratic, right? When I go ahead and distribute, what do I get? X times 140 is 140x. And x times negative 2x is negative 2x squared equals 2,000. Let's get this in the proper form, right? That is, subtract 2,000 from both sides. Let's also put our leading coefficient of negative 2x up front. So negative 2x squared plus 140x. And then, maybe I should have showed a little more here. Subtract 2,000 off of both sides, right? And when you do that, that minus 2,000 shows up on the left-hand side, whoops, one more zero, of the equal sign. And that's what we've got. Okay, now what? Well, look at the leading coefficient, it's negative 2. But if I could factor that out, meaning is there a factor of negative 2? And there is. So I would recommend definitely factoring that out because it will be easier to work this problem. Factor out a negative 2, it's like dividing each term by negative 2. So now negative 70x plus 1,000. So we just made the numbers half the size as they were before, which just makes them easier to work with. So we should have negative 2 times the quantity x squared minus 70x plus 1,000 equals 0. Good news. This is now considered an easy problem, other than the numbers are big. But once we find those two numbers, we don't have to go through the process of grouping. Whoops. Can I move this over? Guess I can't. Thought I could. Okay, so we don't have to go through the process of grouping. So what we're going to do is we're going to say with a different color. We're going to say, with a different color, come on, we're going to say what two numbers will multiply to 1,000 and will add to negative 70. So these two, negative times a negative gives us a positive and can add up to 1,000. So the downside of this one is that, there's many factors that multiply to 1,000. And starting with 1 times 1,000 is going to make this list super long. Remember what's going on here. We have two negatives that are going to work together to add up to a negative 70. So you're going to have two numbers that add to 70. So, 1 and 1,000 are really off base. There's no way you can add those to get to 70. So we need smaller factors. So what you could do is you could say, well, I could say 2 times 500. Those are still really far away from adding to 70. So what if we think about the idea that 1,000 is just, whoops, how'd that take off on me? 1,000 is just going to be 10 times, 100 is 1,000. 10 times 100. And that might kind of get some ideas going. That still's not going to add up to 70. But what if I made this, double this, 20? How about 20 times 50? 20 times 50 is 1,000. And 20 times 50 also sounds really good for adding to 70, or negative 70 in this case. So negative 20 and negative 50 are our factors. And we're really happy that the rest of this is, we don't have to group it. So negative 2 times the quantity of x minus 20 times the quantity of x minus 50 equals 0. Set each factor equal to 0. So x equals 20. Set the second factor equal to 0. So x equals 50. We're actually getting two answers for x, two possible answers for x. They would give us the same, they would use the same amount of fencing, 140 meters, and give us the same exact square meters inside. There's actually two values of x that will do that. Let me go ahead and draw you a picture. And let's see, we had a river, right? And then we had this fencing. And we said the x was 20. So what's the y that goes along with that if x is 20? Well, we have to go up to our equation up here. What was that equation again? The equation that we had was right there. Ooh, that doesn't really show much, does it? Purple. We had an equation that says y equals 140 minus 20. Oh, there it is again. Y equals 140 minus 20. Um, 140 minus 2x, not 20. Did I say 20? 2x. 140 minus 2x. Well, we know what x is. We know what x is. We know x is 20. So x replaces that 2, and now we have our y. So y equals 140 minus 2 times 20. So 140 minus 40. So y must equal 100. And there was another answer, this one. So this one produced that drawing. And this one's going to produce this drawing. Here's a river. There's the little cows that I guess never go in the river and won't run away. Or you don't have any predators sneaking in from the river, I guess. It's a very trusting farmer. I want to make sure you don't get the wrong idea that this, just call this square, otherwise that problem gets a lot harder. So now remember, in our scenario here, the x is 50, so this is 50. I guess if I was going to try to draw it to scale, maybe I should, just to be a little more realistic. This particular enclosure has a bigger width, but the width is not going to be big. Okay, it's not drawn to scale. Sorry, I didn't draw it to scale. I'm disappointed in myself as well. So now the x value is a little bigger than the other one. So that's 50. That's also 50, but really we want to know what this is, and we have an equation for that. Remember that y equals 140 minus 2 times x. And what is x in this case? Well, it was 50. So remember, we can go ahead and replace our x value with 50. And away we go. 2 times 50 is 100. So y equals 40. So there are the two particular drawings, the two particular dimensions that will produce an area of 2,000 square meters. If you multiply length times width, you'll find that they both will produce 2,000 square meters. Let's go and find the answer. Thought the answer, the way they did this, was a little bit sketch, but it says, okay, we want something that's 50 meters by 40 meters, and the 40 meters is along the river. Okay. 50 meters by 40 meters, and the 40 is along the river. And so this is also 40, right? But there's no fence there. So I thought that was, you could kind of read into that the wrong way. So this is the situation they want, though. The length of 40 is along the river, but remember there's no fence there. So I thought that was a little wacky how they said that. So yeah, 50 by 40, and the 40 is along the river, and then the other one is 20 by 100, and the 100 is along the river. Okay, so 20, there it is, 20 by 100, and remember this is also 100, so 100 is along the river, and so that A is the correct answer. All right, so that last one was definitely challenging, a word problem that used a polynomial, a quadratic more specifically, to solve the problem. These are a bit challenging, but I needed you to see one. In the future, you could see these if you continue on to pre-calc and stuff like that. Okay, I hope you had a great day or are having a great day, and we'll talk to you soon. Bye.